With technology changing and the modern vehicle becoming more technically challenging, it's easy to forget the basics.
Always test and confirm a system's mechanical operation before making a diagnosis. Never condemn a component unless you can guarantee it's at fault. For an internal combustion engine to operate correctly, it needs 4 elements: fuel, air, spark, and compression.
This video is part of a series explaining how to accurately test each element.
We'll look at compression testing, the correct way to do this important task, and the reasons why. Internal combustion engines depend on correct compression of the air-fuel mixture to maximise the power produced by the engine. If the engine's combustion chamber leaks, then some of the air-fuel mixture will escape during the compression cycle. This results in a loss of power and increased emissions. An engine with poor compression will not run efficiently. If the symptoms suggest that the cause of the problem may be cylinder pressure loss, then a compression test will need to be performed.
There are 3 different types of cylinder testing: static, dynamic, and electronic. A static compression test is relatively easy to perform, and when done correctly, will give you the most accurate measurement.
A dynamic compression test is more involved and is not possible on all vehicles, but it can point to potential issues that a static test cannot.
This is because a static compression test only checks a cylinder's ability to seal, whereas a dynamic test can isolate airflow problems. An electronic compression test is very easy to perform, but is the least accurate of the 3. Once you have determined that a compression test is required, a compression test analysis form should be used. This form should be attached to the repair order or job card. Most cylinder compression testing should be carried out with the engine at normal operating temperature.
An electronic test is a fast way of determining if there is a cylinder with low compression. This can be done using a scan tool or an oscilloscope. Let's have a look at this one first. An unequal reading can indicate a problem in the fuel, air, and ignition system or compression pressure for that cylinder. This testing procedure simply identifies that there is a fault in one or more cylinders. A static compression test will be required to pinpoint the fault.
To begin, remove the high tension leads or coil packs and loosen the spark plugs a few turns. Reconnect the ignition source and restart the engine. Open and close the throttle a few times and then switch off. The reason we do this is to eliminate the chance of any foreign material being dislodged by the removal of the spark plugs. This material may be trapped between the valve and valve seat, causing an incorrect reading. Disable the fuel system. Disable the spark by disconnecting the primary side of the ignition system. Some scan tools have a compression test function. When selected, it will disable the injection, spark, and hold the butterfly in the open position. Remove all the spark plugs and inspect. Always keep them in cylinder order. This may help isolate a cylinder fault. Inspect the cylinder head threads and the plug seat closely. Any debris sitting here will not allow the gauge to seal correctly and cause a false compression reading. Connect the compression tester. If the vehicle has electronic throttle control, disconnect the throttle valve harness connector and prop the butterfly in the open position with a suitable wedge. Failure to disconnect the harness may cause damage to the throttle motor or valve. The reason for holding the throttle butterfly in the wide open position is to allow a full charge of air to be drawn into the cylinder. This guarantees an accurate reading.
Always start at number 1 cylinder and work sequentially to the last. Crank the engine a minimum of 6 revolutions or until the needle stops rising. Record the result on the chart. Continue measuring all of the cylinders, ensuring the number of revolutions per cylinder are equal. Record the results. Compare your results to specifications. All compression readings between cylinders should have a maximum variation of 10%. This is allowable due to age and normal engine wear. If any cylinder has a substantially lower reading compared to the others, then further testing will be necessary.
Next, we'll carry out a wet static compression test. We do this to help isolate the fault. Put a small amount of low viscosity engine oil into the cylinder that you are testing. The oil will coat the outer edge of the piston and rings, creating a seal with the cylinder bore. Be aware, on horizontally opposed engines, that this might take a few attempts as the oil may pool on the lower side of the piston, making it hard to create a seal. Reinsert the compression tester in the cylinder. Crank the engine a minimum of 6 revolutions, or until the needle stops rising. If the cylinder pressure has now increased to specified levels, the fault will most likely be the piston rings or bore. If the cylinder pressure doesn't increase, then a leak down test will be required. A dynamic compression test is performed with the engine running and the compression gauge connected to the cylinder under test. To commence this procedure, remove the spark plug from number 1 cylinder. If fitted, remove the Schrader valve from the compression gauge. This will prevent the reading from being held by the instrument. Ground the high tension lead on the cylinder you are testing. Start the engine and allow it to idle. Record the gauge reading on your compression analysis chart. Briefly blip the throttle several times and record the highest reading. This will ensure an accurate result. Continue this procedure on all remaining cylinders.
Our analysis chart now comes into play. The first column indicates static compression values. You can see they are all within specification for the vehicle. Our dynamic readings at idle are low compared to the static readings. This is due to throttle position and airspeed within the engine.
At idle speed, our cylinder is only about half full. The dynamic readings should be about half of the static readings.
When interpreting the blipped throttle readings, we should see an increase over the running results. These results should be about 80% of the static test. This is because the engine air volume increased for a short period of time. Although the dynamic compression test is very time-consuming, the increased RPM during the test may reveal problems that a static test cannot. The main area to look at here is the blipped throttle results. If these results are much lower than 80% of the static readings, then check for airflow restrictions on the intake side of the combustion chamber.
Problems can include worn intake cam lobes, excessive valve clearance, worn intake guides, or heavy carbon deposits on the intake valve or in the intake manifold. If all blipped throttle readings are high, then look for an issue that affects all cylinders. A blocked catalytic converter or exhaust may be the culprit. Worn exhaust cam lobes, excessive valve clearance, or collapsed hydraulic lifters may be the cause of an individual cylinder high blipped throttle reading. As you can see, a static compression test gives us a good indication of what is happening in the combustion chamber, although it will only indicate loss of compression. The dynamic test also gives us information on airflow through the cylinder.
Performing a leak down test will isolate any cylinder pressure loss found during a compression test.
There are two types of cylinder leakage tester, single gauge and dual gauge.
We'll be using a dual gauge type for this test. One gauge displays regulated pressure, while the other shows cylinder leakage. A single gauge tester displays cylinder leakage only. Always zero your gauge before conducting a test. Again, the engine must be at normal operating temperature. Remove the spark plug on the suspect cylinder. When performing this test, it's critical to set the affected cylinder's piston to top dead centre on its compression stroke.
This ensures both intake and exhaust valves are closed.
Secure the crankshaft to prevent the engine from rotating. Install the correct fittings to the spark plug thread and connect compressed air to the leakage tester. Set the regulator to the specified pressure and monitor the cylinder leakage gauge. It's important to have the correct air pressure supply as the leakage gauge is calibrated to operate in a specific range. The maximum allowable cylinder leakage is 20%, with variations between cylinders of no more than 10%. There's 4 places cylinder leakage may occur: the intake valves, the exhaust valves, the crankcase, or the cooling system.
If high leakage is evident, open the throttle valve and listen for escaping air. If air is heard or felt, then the intake valves are the likely cause. This could be due to incorrect valve clearance or timing, carbon buildup, burnt, bent, recessed or sticking intake valves.
Remove the engine oil fill cap and listen or feel for any air movement. If there is large flow here, then air is leaking into the crankcase. This could be due to piston, ring and cylinder, or head gasket damage. Remove the radiator cap and watch for air bubbles. If these can be seen, then the compressed air is entering the cooling system. Cylinder head or gasket damage is the most likely cause.
Listen closely at the exhaust outlet for any airflow. If air can be felt or heard here, then the fault will lie with the exhaust valves. Before removing the cylinder head for any work, confirm the valve clearances aren't at fault.
It's essential that all mechanical checks are carried out when performance testing an engine. Where possible, try to use 2 separate tests to confirm a fault.
A compression loss may be a symptom and not the root cause of the fault. Check all ancillary systems to confirm this.
Remember, always diagnose, don't guess. Thanks for watching. See you next time.